So in this video, we're going to start linking the gameplay controller and the track view. And so the first thing I want to do here is to complete the gameplay controller, and by making sure that it stops whenever it reaches the end of the track. I want it to stop. So what I'm going to do here is add an I enumerator that I'm going to use for a coroutine, because I want I want it to stop at the end, but I want it to wait enough time so that the track view completely goes out of screen. So what I'm going to do here is then say that I want it to yield, and so I'm going to add here. I'm simply going to add a private wait for seconds, which I'm going to call wait and stop, like this. And in awake, I'm going to say wait and stop equals new wait for seconds, and I'll pass here simply the bits per second times 2, so that it waits for 2 beats. And I could just use the different information. I could use the number of beats in the outro, for example, or something like that. And so I'll just come back here and then say that I want it to yield return wait and stop, like this. And then I'll say enabled equals false, so that it turns itself off whenever it's finished playing the track. And now what I'm going to do here is then say that after it's completed here, then I'm going to say start coroutine, and then I'll pass the wait and stop method here. So now that I have this, I want to be able to fully bind the track view with the gameplay controller. And whenever you have two components in a dependent architecture, you have one component that is dependent on the other. You don't want to have mutual dependency, and it's always better when you do not have a component to assign another or create another. And it's always better when one is simply saying that it will look for the other one, and it will eventually subscribe to its events and things like that. So for this, what I'm going to do is then say that the gameplay controller is most probably the one component that will always be there. This is the one that references the track, and this is the one that will dictate most of the behavior of the gameplay. So this is the one that we want to have all the time. And so what I'm going to do here is then say that I want this to be a singleton, and a singleton is another paradigm that is totally compatible with any other design pattern. Actually, design patterns are just like references, and you can modify them and make them somehow the way you want. They're just like patterns, and not just like fixed architecture that you cannot modify. So what I'm going to do here is then use a quick code snippet that I'm using here, and which allows me to say that I want a gameplay controller, which is the instance. And so if we have a quick look at what it does here, is that it references a static reference to a gameplay controller, and whenever we access it, whenever we access the instance, then it will go, and if it doesn't already exist, if it's not already assigned, then it's going to go and look for one in the scene. If it doesn't find one, then it's going to go and create one. And so creating one here doesn't make so much sense, because it requires to have information such as which track it has to play and so on. So I'm simply going to get rid of this and simply say here that I want to get rid of that. And there I'll just say if the instance is null, then I want to go and find it in the scene, and that's it. And then I want to return it. And this is like some very common pattern here. And what I want to do here is then say that I want the instance to equal this in awake. And so this is what I'm going to do here, like that. And one important thing is when you do singletons is to make sure that whenever you unload a scene, for example, because you load another scene or something, then you want to make sure that when you do on destroy, and actually I used on disable, but I'm going to do on destroy instead. On destroy, then instance equals null, and there I'll just use the underscore one so that I can get rid of the set, because I don't want any other component to be able to change the instance to the gameplay controller. The gameplay controller is set up in the scene. So let's just quickly go back in the editor here and make sure that we that everything runs smoothly. All right. And now what I want to do is then go back in the track view here. And so instead of having to assign a track view or to assign the gameplay controller to the track view and say, hey, track view, this is the gameplay controller. And on the other hand, I would be doing like, hey, gameplay controller, this is the track view. I don't want to have to do all these kind of bindings. I want it to be automatic. So to do this, I know that the track view will never exist without a gameplay controller, which may not be true in the other way around. We may have a gameplay controller without a track view, but not the other way around. So what I'm going to do here is then say that I want to initialize whenever I'm going to go in the initialize here. I'm going to go in the start, and for example, instead of initializing the track view with its own track property, I'm going to go and say gameplay controller dot instance dot track, and so it's going to go and find the instance of the gameplay controller and then find the track property, and so which allows me to simply get rid of this manual track reference that I had so far here. This is pretty useful, pretty handy, because I don't want to have to handle different track informations, one in the track view, one in the gameplay controller, and so on. Within the init method, I want to reference the size of one bit view and the size of the spacing, because I know that the bits in the track view can be laid out with some spacing. So what I'm going to do here is then simply say that after this position here, I'm going to add a float, which I'm going to call bit view size, and another one that I'm going to call spacing, like this. And whenever I initialize this, then I'm going to say bit view size equals, and I'm simply going to use the empty, and I'm going to go get the rect information here and the height of the rectangle of the empty transform. And there I'm going to say that spacing equals get component, and then I'll pass here a vertical layout group dot spacing, like this. And I know that I've got a vertical layout group because I've added before the require component vertical layout group. And so I'm taking the spacing here, I'm assigning the spacing float value and the bit view size. And so basically what I need to do here is then say that using the time delta time, I also want to multiply this by, I'm actually going to multiply this by gameplay controller instance dot seconds per beat, and I want to use the seconds per beat, as I'm going to use the beat view size and the spacing together, which is the amount of translation that I need to do whenever we move forward of one beat. And so I want to multiply this by the number of seconds per beat, so that we can multiply this by the delta time, and so we should get a translation that follows the proper speed. And so there I'm simply going to say bit view size plus spacing. So now let's go back in the editor here, and let's have a quick look at the track view component here, and we can see that the track view no longer references a track. It will automatically find the gameplay controller and bind itself to it and find its track property. And so now if we do this, we should see that it ticks properly, and that the speed, I should be able to get a lot more right combinations that before. So now instead of relying on the console to see if we've played properly or not, we're actually going to make it so that the track view displays and changes the display for every beat whenever we play them properly or not. And this is what we're going to be doing in the next video.